All right, welcome to our lecture on significant figures. This is exciting stuff, guys. All right, first off, significant figures is so formal. We are just going to call them sig figs, okay, for short. Sig figs for short, it's like their nickname. All right, so sig figs. Sig figs are super important. Why? Well, because they tell us how precise a measurement is. Okay, so if we have these three rulers here, like you see here on to the right, if you have a ruler that says 100 centimeters on the very end and you have no lines in between, can you make a very precise measurement with that ruler? The correct answer is no. You cannot make a precise measurement with that ruler. All right, so it's not going to give you a very good or precise amount of sig figs. Okay, you're not going to have very good sig figs. In fact, here, if we're trying to figure out the measurement of that line, and all we know is that this is 0 and this is 100, we would say maybe 20, right? And so we're going to find out that that's only one sig fig. That's, kind of lame in terms of sig figs. So the more sig figs given, the more precise a measurement. If we take a look at the second ruler, hey, we got some lines here. So now we could say, all right, yeah, it is 20. In fact, we could say it's probably like 23, okay, centimeters. Good thing we put our units down, centimeters. Right? And so look, we've got 2 sig figs. We have just increased the amount of sig figs by putting more lines on our ruler. And guess what? Check out the last one. Oh, lines galore. In fact, we can see there it's not 23, it's actually 22 and a half probably. Okay, centimeters. So 22.5 centimeters, and check out what we did with our sig figs. Look, we have even more digits. More digits mean more precise measurement, and that is a good thing when we're working with measurements in science. We want to be as precise as we can be when we're doing our measurements. All right, so what the heck does precise mean? All right, so let's take a look at something called precision versus accuracy. So precise means giving more exact or detailed information. And heck, yes, that's exactly what we did with our rulers, right? This one gave us no information. That was lame. But as we go down looking at the rulers, we get more and more exact or detailed information about the measurement, right? So that's what precise means. So the more sig figs you use in your measurement, the more exact or detailed it is, bottom line. Okay, and precise and accurate are kind of used hand in hand. So what does it mean to be accurate? Accurate means to be close to the real or accepted value of something, so to be on target. So if scientists have measured the distance from the Earth to the moon, right, and we kind of believe them as being the accepted or real value, and you have measured the distance from the Earth to the moon and you didn't get nearly as what their measurement was, then you could say that you are not accurate. All right, so an easy way to kind of visualize the idea of precision versus accuracy is to take a look or to liken it to a bullseye target. So if we take a look at this first one, we have all of the little, bullet shootings, okay, in a little cluster, but it's nowhere near the target, right? It's nowhere near the bullseye of the target. So they are precise, okay, meaning that they are very close to each other, and if these all represented, the measurements that we got from the taking a look at the same measurement on a ruler over and over and over again, we'd say they're precise. You get around the same measurement all the time. But are they accurate? No, because they never hit the actual bullseye. Okay, so these measurements are precise, but they're not accurate. Okay. Now, the second one, this one here, they're all kind of around the bullseye, right? So they are accurate, okay, but each measurement is not real close to each other. So we can say that they're not very precise. So, perhaps, somebody was, different people were using a ruler like the second one here, where, it could give you pretty good, accurate measurement, but there could be a lot of wiggle room because there's not, enough detail on it. Now the third one, this is all over the place. This is like somebody, one person in your group used the ruler up top and the other person used the ruler in the middle and the other person used the ruler on the bottom, and we're all over the place. So they're not, precise or accurate at all. Okay, so that one does not show either. And then this one, boom, right on target. Check it out. This is like a group, a lab group that, works super intricate, delicately, makes sure their measurements are awesome, right? So we've got all of the measurements are together, close together. So that means that they, were very spot on in measuring each time, okay, measuring the same each time, and their measurements were also close to the accepted value, or they were on target, they were on the bullseye. So this is precise and accurate, okay? So if you have, the more sig figs you use in your measurement, the more exact or detailed it is. And if you measure with more sig figs, you'll have a better chance of being accurate in your measurements as well. Okay, so that's what we're always striving for in every science class, including this one, to be both precise and accurate. So significant figures are going to help us do that, and they're going to also help us do math. So you may be asking yourself, how do I figure out what numbers in a measurement are important or are significant? Well, here is some clues. All non-zero numbers are significant, so they always count towards the precision of a measurement. All right, so that means the only numbers that may not be significant, I won't say are not, but may not be significant, are the zeros. Okay, so your zeros are the tricky ones. So the zeros are what we need to kind of focus on. So there's a real easy trick in order to figure out if the zeros count towards the precision of a measurement or if they are just there as placeholders. So this rule is called the Atlantic-Pacific rule for zeros. And it, yes, is named after, I should say, the oceans on both sides of the United States of America. The Atlantic being on this side. All right, the East Coast gets the Atlantic Ocean, and the West Coast gets the Pacific Ocean. All right, so we're going to start with a number that has a decimal. Okay, so the decimal, if a number has a decimal, that's going to be super important. So if a decimal is present, okay, then you're going to swim from the Pacific Ocean. So let's do an example here. If we have the number 0.00360 millimeters, okay, that's our measurement. So the first thing we ask ourselves, is there a decimal? Yes, there is. There's a decimal right there. So if there's a decimal present, then you need to swim from the Pacific Ocean. All right, swim meaning, you count or you go towards the number from the Pacific side. So we're going to start over here and we're going to swim through all the zeros. Those are like, fun hoops to swim through. And boom, as soon as you swim through all the zeros, you hit your head on the first non-zero digit. So you stop when you get to that first non-zero digit because you just hit your head smack on the wall, right? And you look up, all dizzy, and you're like, oh, how many digits did I just run into? And you look up and you count. Oh, I ran into 1, 2, 3 digits. There must be 3 sig figs. There must be 3 sig figs in this measurement, and indeed you would be correct. Okay, these zeros in front were just placeholders, okay, telling you that it's a small measurement but not telling you the precision of the measurement. Okay, so that's when a decimal is present. Let's take a look at one more example. What if we had the number 36.00? Okay, well, again, our first question is to ask ourselves, is there a decimal? And you'd say, yes, there is a decimal. So if the decimal is present, we're going to be coming from the Pacific side. So that's this side here. So we're going to come swim to the Pacific side. There's no hoops, there's no zeros in front to swim through. So bam, we hit our heads, boom, right there. First thing, we take a look and we say, ouch, how many numbers did we just run into? We count them all. 1, 2, 3, 4. So there must be 4 sig figs in this number. And so we can see here that the zeros do count as significant figures. All right, and the way we can think about it is that this measurement is not just 36, it's 36.00. It tells you it is super precise number. So these zeros do count in sig figs. They are not placeholders. All right, they are telling you how precise that measurement is. All right, so let's take a look and use this rule for if a decimal is absent. Okay, so let's take a look at the number 3,005. That's 1,580. Okay. In this number, again, the first question you always ask yourself when you look at a number is there a decimal? In this case, there is not a decimal. So we're going to be coming from the Atlantic side. We're going to be coming from this side. And so we're going to swim through all the zeros. Those are hoops to swim through. And bam, we hit our heads on the 8, right? That's our first non-zero digit. We look up and we say, ooh, how many digits did I just run into? And we count them. 1, 2, 3. So this guy has 3 sig figs. Okay. So this 0 here, all right, did not count in the precision of the measurement. It's just a placeholder to get it to the thousandths spot, all right? So whatever they're using, whatever tool that they're using to measure is not super precise, all right? It kind of gives you, 3,580, but it could have been, rounded up 305,000 or 3,579, and they just kind of rounded it up to 80. Who knows? All we know is that last 0 there is not counted as a significant figure. Okay, so let's take a look at one more example. If we do, let's say, 100,000. Okay. All right, again, there's no decimal. The decimal is absent. So we're going to come in from the Atlantic side and look at all these hoops. Look at all that fun we get to swim through. Bam, we hit our heads on our first non-zero digit. Okay, we look up and we count. There's only one of them there. So that means there's only one significant figure in this measurement. All right, so all those zeros are just placeholders telling you that it's in the, oh, that's millions, huh? In the millions spot, not 100,000, like I said earlier, duh. All right, it's in the millions spot. And so there's only one sig fig here. And all those zeros are just placeholders telling you that it's a really big number, but it's not a very precise number. So it could have been a number, a rounded number, or using, one of those rulers that was 1,000,000 inches long and there's nothing else, no other little hash lines to measure with. Okay, so that's how we're going to figure out if a measurement or how many sig figs a measurement has. So once again, if the decimal is present, you swim in from the Pacific side, through all the zeros, stop when you get to the first non-zero digit, look up and count how many you just ran into. And then if the decimal is absent, you swim in from the Atlantic side. Again, swim through all the zeros, look up and see how many digits you just ran into. Okay, so your question now is, why the heck do I need to know this? Okay, why do I need to know about significant figures? Well, eventually we're going to start doing some math. I know, it's scary. Some math and chemistry. And so when we are using our calculators, you won't ever ask me to, what do I round to, Mrs. Creel? Because I'll just say sig figs. All right, now when we get there, I'll teach you, how to figure out how many sig figs to round to. But that's kind of, where we're going. So the first step is to figure out how many sig figs are in a number. And then when we start doing some real math and chemistry, I'll teach you how to figure out what to round to. But that is going to be kind of the culmination, the why do I need to know about sig figs? So you don't ever have to ask me, okay, this irritating question of what do I round to? Okay, you'll just know because of sig figs. All right, that's all.